Okay, so we're going to be looking at the 8.1 through 8.3 review for this quiz. So if we look at 1 through 5, what we'll notice is that I already have them filled out. Sorry about that. But one way that we can notice if it's arithmetic or geometric is by plugging it into our calculator under menu 7 and getting the table. Or another way that we can identify if it's arithmetic or geometric is by plugging in values for n. And the last way we can figure out, once we figure out where it's arithmetic or geometric, we can find the D or the R by either one of those methods as well. Another cool trick to kind of notice is that anytime n is inside the equation, like for 1 and 4, that's where it's arithmetic. It's going to be geometric anytime n is in the exponent. And it's going to be neither anytime n is taken to a power of something. So anytime you have an exponent on the n, that's where it's neither. So now if we look at 6, the work that we had started on 6, we notice that it's a geometric sequence from the problem, and we need to find the r in order to fill in the missing terms. So I use this formula right here, and then at this point I can either plug in equation solver, or I can figure out the algebra and do 1 over 156 times 39 over 64 equals r to the 4th. And then when I take the 4th root of whatever that is, I get plus or minus, because anytime I have an even power and I take the root of that power, so square root, 4th root, 6th root, it can always be plus or minus that term. So this should be plus or minus 1/4. And so then we get a sub n is equal to 156 plus or minus 1/4 to the n minus 1. And then we plug in 2, 3, and 4 in order to solve for the missing terms. So we should get something like plus minus 39 39 over 4, and then plus minus 39 over 16. So that's what we should get for 6 right there. And then if we write the explicit formula for the nth term, that would just be this right here. So a sub n is equal to 156 plus minus 1/4 to the n minus 1. So that's all we would need to do for 6. For 7, we're now dealing with an arithmetic sequence, and we're given the 2nd term and 3, 4, 5, and the 6th term. So now we're dealing with something different because we're dealing with slope. So since we're dealing with slope, we can rewrite these as coordinate pairs, 2, 15, and 6, 65. So I can find my d by finding the slope of this. So 65 minus 15 over 6 minus 2, which is equal to 50 over 3. I'm sorry, I can't do math. 6 over 2 equals 4, which is equal to 25 over 2. So this is equal to d, which is our slope. So now we can write this, we can figure out our first form by just simply subtracting 25 over 2 from that. So we get 2.5. And then we can now, since we have the first term of the sequence, write this in explicit formula as a sub n is equal to 2.5 plus n minus 1 times 25 over 2. And now we can plug in 3, 4, 5, and 6, or 3, 4, 5, and 7 in order for us to get the remaining terms. So 27.5, 40, 52.5, and 77.5. So the big thing that we have to remember, the difference is between is arithmetic, we have the is the slope, and geometric, you cannot do that. You're gonna have to be able to plug in and find for the R. Next up, we have number 8. And we want to find the indicated term for each sequence, and then find the sum of all terms from A1 to the indicated term, and then circle our final answer. So we're first looking for the 8th term, so we have to identify which formula we're using from the top. So I know I'm using an geometric sequence here, so I have a sub n is equal to a sub 1 times r to the n minus 1. So I plug in what I know. I know that I'm looking for the 8th term. I know that my first term is negative 10, and I know my r is 2 and 8 minus 1. I can then find my 8th term, and it is negative 1280. So that is my 8th term. And then the sum for the first 8 terms can be, we now have a sub 1, which is still negative 10, and then parentheses 1 minus 2 to the 8th over 1 minus 2. I would plug this in exactly how you see it every time on the calculator, and we get that the sum of the first 8 terms is negative 2,550. So that would be all we have to do for number 8. For number 9, now we're dealing with arithmetic instead of geometric. So we have, again, that our first term is 43. That's given, and our difference, our slope, is 5. First thing we want to do is identify the formula and find the 72nd term. So I have a sub 72 is equal to a sub 1 plus n minus 1 times d. Plug in what we know. We know we want the 72nd term. So a 72 is equal to, we know the first term is 43. 72 minus 1 times 5, because we know our d is 5. Do the math there, and we should get that our 72nd term is 398. So if we're looking for the sum of the 72 terms, we use our arithmetic series formula, which is s sub 72 equals 72 over 2, a1, which we know was given to us as 43, plus what we just solved for is 398. And that gives us a final answer of 15,876. So now for both of these, we have found the term that we were looking for and then applied that and to find the sum for that series of the terms that we were looking for. So let's take a look at the back page now. We want to do something very similar, except here, now instead of being given the first term, we're actually going to have to solve for it. So arithmetic sequence, we know that we can write these as coordinate points. So we solve for d is equal to 395. And so we get d is equal to 3. And so here's kind of a tricky part. So we write down our arithmetic formula, which a sub n equals a sub 1 plus n minus 1 times D. So what we know, we have to look at what we know. We know two different terms of our sequence, and we know our D is 3. So if I use one of these terms, like for example, I'm going to use a sub 120. So if I use the 120th term of the sequence, I still don't know a sub 1, plus I know I'm using n as 120 minus 1 times 3. Now when I plug in 395 here, I can get 120 minus 1 times 3, to the point that I am now only having to solve for a sub 1. I just have to do that math. So when I do that, I get a sub 1 equals 38. So now that I know a sub 1, I'm going to be able to solve for the 272nd term of the sequence. So a sub 222 is equal to 38 plus 222 minus 1 times 3. When I do the math for that, I get 701. And now I want the sum of all 222 first questions. So I get 222 over 2 times 38 plus 701. So I get these numbers from, this is my n, 38 is my first term, and 701 is the last term that I want the sum to. So we have all of those all of that. So now we can get that this is equal to 52,029. And there is the sum. So now for number 11, we want to solve for the geometric. We want to solve for the fourth term. And to be able to do that, we are going to need to plug in. So remember, for our geometric, we have a sub 1 times r to the n minus 1. But since we're not given the first term, and we are given two different terms, we're going to change this 1 to an m. And remember, we want our n to be bigger than m. So 5 and 8, so we're going to use 8 as our n. So a sub 8 is equal to a sub 5, r 8 minus 5. Plug in those values. We get that r is approximately 0.459. So now we choose which one we want to use. I want to use a sub 5. So I get 38 equals a sub 1, which I still don't know, 0.459. 5 minus 1. I do the math there, and I get a sub 1 is equal to 856.116. And now I can finally plug in for a sub 4 is equal to 856.116 times 0.459 to the 4 minus 1. And I get a sub 4 is equal to 82.789. And then for the second part of my question, I want the sum of all four of the first numbers. So I get 856.116, parentheses 1 minus r, which is 0.459, to the n, which is 4, over 1 minus 0.459. And that gets me 1,512.229. For number 12, I want to see if this is an infinite sum. So if we remember what is the case when we have an infinite sum, we know our formula is this. S sub infinity is equal to A1 over 1 minus R, because basically what is on top in our geometric formula, we're saying in an infinite series that this is going to eventually go to 0. So due to that fact, we can use that. We just multiply that A1 out. I'm sorry, that this is eventually going to go to 0, so your total answer is going to be 1. So in order for us to be able to use that, and we look at question 11, our R needs to be less than 1, plus or minus 1. So for this, if we're ever going to have a solution, our R has to be in between -1 and 1. So if we look here, our R is 0.459. So of course we know that that is is less than positive or -1. So this can be written as an infinite series. So we take the first term again, which was 856.116 over 1 minus R, which was 0.459. And that gets us 1,582.470. So that is our infinite sum. So again, if I gave you something, side note, if I gave you something that asked for the infinite sum, and it was something like 4 to the n, this would not be it, because this would diverge. This has an R equal to 4, which is not in between -1 and 1. So that's something to pay attention to. That would be something really silly to get points taken off on a quiz because we weren't paying attention to that. The last thing we have is this word problem. Philip and Trevor are best friends and went to see the National Cup Stacking Finals. They decided to try and recreate the winning cup pyramid. The top row of the winning pyramid had 1 cup. The second row had 3. Third row had 5. If there were 8 total rows, how many cups should Trevor and Philip buy in order to recreate the pyramid? So we know that we had 1, 3, and 5. So obviously we can tell this is arithmetic. And obviously we can tell that our slope is 2. So if we want the sum of the 8 cups, which is the sum of that would be 8 over 2 parentheses a sub 1 plus a sub n. We have a sub 1, but we don't have the 8th term, so we need to solve for it. So a sub 8 is equal to 1 plus 8 minus 1 times 2, which is equal to 15. So now we have all of this information. So 8 over 2, the first term is 1, plus our 8th term, which is 15. So we get 16 times 4. So they need to buy 64 cups. So that's going to be all for our review on 8.1 and 8.3. We won't have too much time to go over any of this when y'all get to class on Wednesday and Thursday before y'all take the quiz. So please, if y'all have any questions, come in Wednesday or Thursday before school to ask those questions about the quiz.